Welcome to The Circuit, the new face of the Concentrics podcast and your compass in the dynamic world of Concentrics. This season is called Tech Talk, where we will learn about natural language processing applications, techniques, and its use cases. Join us as we journey along the tracks of technology and customer experience in the advent of new trends. This is Tech Talk, where innovation meets consumer satisfaction in the digital age. Welcome to the fourth Tech Talk microlearning session. We hope that at the end of this microlearning session, you will have a better grasp of natural language processing, also known as NLP, and its applications, as well as the fundamental concepts behind the techniques and algorithms used in NLP. Let's get started. First, let's check what the book says about NLP. Natural language processing, or NLP, is a field that uses computational linguistics, statistical models, and machine learning to help computers recognize, understand, and generate human language in text and speech. It is a subset of artificial intelligence that is being utilized in a wide range of daily products and services. Most of us are familiar with robots that can interact with humans, such as C-3PO, Bumblebee, and Optimus Prime. Although they are fictitious characters from movies, the idea that robots can converse and reply in a human-like manner is already a reality, and it is becoming more realistic by the day. Chatbots and virtual assistants such as Alexa and Siri are just a few examples of non-human interactions that occur in our daily lives. NLP is extremely useful in a wide range of AI applications. NLP begins with something known as unstructured text. Just like how humans speak. Let's take this example.
Add exercise and laundry to my to-do list.
For this instance, the unstructured text is add exercise and laundry to my to-do list. Everyone watching this video understands what it means, yet it is unstructured for at least a computer. In this case, we need to create a structured representation of the same information that a machine can process. Now, it may look something like this, where we have a to-do list element, with sub-elements within it, such as an exercise item and a laundry item. This is an example of a structured text. The purpose of natural language processing is to translate between these two things, therefore NLP is right in the center, translating between unstructured and structured data. The transition from unstructured to structured is referred to as NLU, or natural language understanding, and the transition from structured to unstructured is referred to as NLG, or natural language generation. For this microlearning session, the focus will be from unstructured to structured text, or NLU. Let's now look at some use cases where natural language processing can be useful. Some examples of NLPs that we use on a daily basis include autocorrection on your phone or laptop, and plagiarism checkers that checks your work with publications on the web line by line to avoid copyright violations. Another interesting use case is machine translation. When we translate from one language to another, we need to understand the context of that sentence. It's not just a case of taking each individual word from, let's say, English and then translating it into another language. It is critical to understand the overall structure and context of what's being said. Here are some interesting examples. For instance, translating the phrase "spirit is willing, but the flesh is weak" to Russian.
Дух бодр, но плоть слаба.
If then translated back to English, it may somewhat say,
Vodka is good, but the meat is rotten.
Another example is when translating the phrase "break a leg" to German.
Hals- und Beinbruch.
If then translated back to English, it may somewhat say,
Neck and leg break.
This level of translation loses the idiomatic encouragement of the phrase. NLP can help in situations like those. Another use case is sentiments analysis, which takes some text, such as an email message or a product or service review, and attempts to extract the sentiments represented within it. For example, is the service review positive or negative, written in a serious tone, or sarcastic? We can use natural language processing to tell us. Finally, another useful example is spam detection, which involves looking at a particular email message and determining whether it is a legitimate email message or a spam, by checking for pointers inside the message's content. Overused terms, bad language, and an improper claim of urgency might all signal that it is potentially a spam. Those are some examples that NLP can do, but how does NLP work? NLP is working with not just one algorithm. It can be thought of like a toolbox, where you can apply the tools or applications within the toolbox to resolve some of the use cases discussed. The input to NLP is unstructured text, either written or spoken words, converted to written text through a speech-text algorithm. The first stage is segmentation, which involves breaking down the entire document into its constituent sentences. This may be accomplished by separating the article along with its punctuations, such as periods and commas. For the machine to fully understand these statements, the algorithm must advance to the next stage, which is tokenization. Tokenization is the process of breaking down a string into chunks. For example, the unstructured text concentrics is a great place to work consists of 7 words, which may be represented by 7 tokens. The next stage is stop words. To speed up the learning process, any unnecessary words that add no value to the sentence should be omitted. Is and a are examples of stop words. After tokenization and stop words are accomplished, the stemming process begins. Stemming is the process of generating a word stem from a given token, often known as a root word. For example, running, runs, and ran all have the same word stem, which is run. In stemming, the process is basically deleting the prefixes and suffixes and normalizing the tense to obtain the word stem. However, stemming doesn't work for all tokens. For example, the words universal and university do not truly derive from the word universe. For situations like these, there is another stage in NLP called lemmatization. Lemmatization takes a given token and learns its meaning using a dictionary definition, from which it may determine its root, or lem. Consider the word better as an example. It is derived from good, therefore the root or lem of better is good. During stemming, the word better becomes bet. I hope you can see how important it is whether stemming or lemmatization is utilized for a particular token. The next stage is part of speech tagging. The process examines where and how the token was used in the context of a sentence. Let's take the word make from the phrase I'm going to make dinner. The term make the phrase was used as a verb. But if the same word is used in a question like, what make is your car? Make is now a noun. Where and how the token is used in the sentence is important. Part of speech tagging can help in determining context of the token within the sentence. The last stage is named entity recognition. During this process, the token is verified to see if it is connected with any entities. For example, an Alabama token represents a state in the United States, but a Lara token represents a person's name. These are only a few of the many NLP tools available. In order to convert this unstructured human speech into something structured that a machine can comprehend, and then apply that structured data to a variety of AI applications, there is obviously a lot more to it. Understanding natural language processing allows everyone to leverage the power of language and technology, creating new potential for innovation and personal development. Dive in to see how understanding NLP may change the way you interact with the digital world. Here are the top 3 books you can read to know more about NLPs. Today, we have learned about natural language processing and its applications, as well as the fundamental concepts behind the techniques and algorithms used in NLP. Thank you for watching. That brings us to the end of the 4th microlearning session. We hope you find the information valuable.